Alright, prime factorization. When a whole number is expressed as the product of factors that are all prime numbers. So for example, 24 is 2 cubed times 3. So you're probably saying, how in the world are you getting that? So the best way to do this is a factor tree. So you're going to take 24 and you're going to say, alright, what times what is going to be 24? So we're looking for prime numbers. So let's see, 2 times 12. I know 2 is a prime number, so I'm going to circle the 2. The 12, I'm just going to box it up. Then my next thing I say, well, because 12 is in a box and it's a composite number, I'm going to go, 2 times 6 will give us 12. So next step is to take the 6 and then go 2 times 3, which are both prime numbers. So I have 3 2's times the 3. Okay. Find the prime factorization of 84. So let's do that one first. So here we've got the number 84. So I'm going to go, what two numbers would multiply will give me 84? Well, I know 2 goes into it, so let's start with 2. So 2 times 42. Well, what are your factors of 42? Well, 6 times 8 are both factors of 42. Wait, is that? No, 6 times 7. My apologies. 7 is a prime number. 6 is 2 times 3. So we circle both those. So now we just go through and count up the number, the 2's, 3's, and 7's we have. So we have 2 2's, so it's 2 squared, times 3, times 7. Always going in ascending order. Okay, next example. Negative 132. So we're just going to forget the numbers negative to begin with, and just look at the number 132. And ask ourselves, what times what is 132? So let's start with, because it ends in a 2, we might as well start with a 2. 2 is a prime number. So what's half of 132? Well, half of 100 is 50. Half of 32 is 16. So 50 plus 16 is going to give us 66. I know that 6 times 11 is 66. And 11 is a prime number. And then 2 times 3 is 6. And then I've got my other 2 prime numbers. So when I write this, I'm just going to write this. Negative 1 times 2 squared times 3 times 11. So there's 2 examples of factor trees. Then we've got prime factorization of a monomial, meaning that you're going to have letters attached to a number. So your first step is just to take your number. So in this case we have 24a squared b to the 4th. We're going to expand that out. So we know that 24, when we do our factor tree, is going to be 2 to the 3rd power times 3. And then we just have to write the letters out. So you have to say, a times a, and then write 4 b's, and then you're done. Let's try this one. So first I'm just going to look at negative 26, forgetting about the negative sign for now. And then I'm going to say, 2 times 13 is 26. So when I write this out, I'm just going to have negative 1 times 2 times 13. Then I'm going to just write out all the letters. So I'm going to expand it out. Then our next step is just to expand the letters. So we're going to go write 1 R. We're going to write 3 S's and then 2 T's. And that's factored out. Alright, then we just want to go over a GCF, which we've already talked about. So G stands for greatest. C is common. Factor. So we factor the monomials, so we look at each of the numbers or monomials they give us, and then we just look for the biggest numbers that they have in common. Or we can also use factor trees. So let's say we had 12. So we know 2 times 6 and then 2 times 3. Right? Then we look at 18. We've got 2 times 9, and then we break down the 9. So we just look at whatever prime numbers they have in common, so they each have at least 1 2 and 1 3. Alright, so let's look for the greatest common factor for 25 and 27. So I'm going to take my 25, and I'm going to find the prime factors of that. Do the same thing for 27. So I'm just going 3 times 9, breaking down the 9. And then I look and I say, well, there's nothing in common. So we just write none. Alright, last one. So now we've got 27 and 15. Okay. So let's break down our 27, which is the same thing from the last slide. Break down the 15, which is 3 and 5. And then we look in common. They have a 3. Next, you look for all the letters they have in common. They each have at least one A and at least one B. So that's how you find the greatest common factor for 27a squared times b and 15ab squared times c.